Okay, hi everyone. So today we'll be going through a workshop Tensorflow IoT devices or mobile devices. So together with me we have Trini also, and today we'll be going through a simple image classification example for both Android and iOS. So if you would like to follow through step by step, please go download Android Studio or Xcode as well, and also have your mobile device ready with you. Yeah. Okay, I guess I'll get started since it's about 7:05 already. So let me just share screen real quick. Okay, so I think Chini already sent the resources for this workshop into the group chat. So it will direct you to this. GitHub link. So the first thing you want to do is to press this. So open this notebook in Colab. And afterwards, please remember to press File, then save a copy in Drive, because this is my notebook, and I think you must save a own copy in your own Drive for you to be able to edit. If not, you can only view my notebook. Yeah, so do remember to press File, then save a copy in your Drive. Yep. Then we just leave it aside first. So I'll just go through some quick details about the workshop today. Yep, so let me just get started. Okay, so today we will just be going through TensorFlow for mobile and IoT devices. So specifically, I'll be doing Android and iOS devices today. Yeah, so this will be the quick overall pipeline for today. So today, first step is to sort of gather a data set and sort of build the data set from scratch. Secondly, we will create a model or select and train a model for a specific use case, which is image classification. After we train a model, then because we are deploying it to mobile devices, so we have to sort of convert the model to Lite format. And last but not least, we'll just be deploying it to our mobile devices, and hopefully everything goes smoothly. Yep. Okay, so let me just go through a quick background first. So today we'll be doing image classification, as I mentioned. So you'll look something like this on the right, where you'll be able to classify an object as a banana, as it says here. So conventionally, we'll usually build like a CNN or convolutional neural network. So an image will be fed as an input to an input layer. Then we'll have a few hidden layers, just build a CNN, and afterwards we'll be able to classify it accordingly as an image. So conventionally, we will collect the image that we want to play around with first. Secondly, like I mentioned, build a CNN model. And last but not least, we'll train and test the model. But that is not what we'll be doing today, because sometimes when the machine learning model lacks accuracy due to insufficient training data. Since we are just doing like a sort of backyard project, so we won't be able to have a lot of data. And as we all know, if we do not have a lot of training data, then the model won't be super accurate. So this is where the concept of transfer learning happens. So okay, so for traditional machine learning, is on the left here, is usually isolated and single task learning. So for example, the first data set, the first task will be to maybe train a model to identify to classify cats and dogs. Okay, and the second task over here will be maybe similar, so image classification as well, but instead of classifying cats and dogs, we'll be classifying maybe fruits instead, so apples, bananas, pears, whatever. So as we can see here, the two tasks or data sets are not exactly linked. So although they are similar, but they are not linked, so they are very isolated and single task learning. For transfer learning, however, as the name suggests, it's really the learning of the new task, which relies on the previous learned task. So, for example, let's say the the task one will be the same thing, which is to classify cats and dogs. And the second task is to classify maybe fruits. So we can see that actually there's a lot of similarities between the first and the second task. So we can sort of transfer the knowledge, because for image classification, although the first task is to classify cats and dogs, like second task is to classify fruits, but maybe maybe the initial stages of learning will be same, which is maybe for the machine to identify lines, to identify edges, to identify shapes. And these can be sort of recycled for our second task. So this is exactly what we are trying to do today, transfer learning. So firstly, we use existing Google machine learning models, which are super optimized and super well trained on other data sets already. And for our part, we'll just make slight changes and tweaks to the model and to fit our images data, and voila, we will be done with our transfer learning model, and we'll just be ready to deploy it to our mobile devices. Yep, so let's hop over to, okay, so let's go back to our pipeline and see what we're supposed to do now. Okay, so the first thing to do is to actually build our data set, right? So to do this, let me just do some everything from scratch. So one of my favorite websites will be to get a data set will be Kaggle. So Kaggle, let me just go Kaggle real quick. Kaggle, yeah. Yeah, your machine learning and data science community. So Kaggle has a lot of data sets, free data sets, competitions, and things like that. But today we're just looking for data sets. So just press on data set and we'll search maybe cats and dogs. And let's scroll down. There's a lot of them. Just pick any one you like actually. So maybe this one, I guess. Okay, 1 second. Okay, let's try again. Okay, something might be wrong with Kaggle. Let me try another data set. Okay, unfortunately, it looks like something is wrong with Kaggle. But anyway, the idea is that there's a lot of free data sets in Kaggle, and you can just press it and just download it. But fortunately for us, already I've already gotten the data set and uploaded it onto the GitHub page. So let me just jump over to the GitHub page first. Yep. So this is the GitHub page that we have, and you can just download this MLDA cats docs zip, and just press download. Yep. Should be quite fast. Okay, so let's hop over to the notebook now. Yep. So okay, so the notebook suggests that this is image classification with TensorFlow Lite model maker. Okay, so TensorFlow model maker is a tool for us that uses transfer learning. So as the name suggests, it makes models very easily. So basically, it has already a few existing models for us to utilize it and to do transfer learning on. Yeah, so that's the idea. So of course, first thing to do is to install the package, which is the TF Lite model maker. Okay, hopefully it doesn't take too long. Okay, yeah, took some time, but it's done. Next thing to do is import some required packages for us. So this includes like operating system, NumPy, basically just the usual stuff, and a lot of stuff from TensorFlow model maker. And specifically today we are using like image classifier model. Yep, so just press import. Okay, next thing to do. So next thing to do is to get the data. So we have just downloaded data just now. So let me just pull out the data real quick. Yeah, a second. So it should be in your downloads. And click on the files and just drag and drop the zip file into this files folder, and just wait for it to be uploaded. So basically, for the data that you downloaded just now, just sort of pull it over to the Colab notebook. Yep. Yeah, it's loading, should be finished quite soon. Okay, cool. So it's over here already. It's in a zip file format. So this code over here is just to unzip it, very self-explanatory. Should be pretty quick. And after you unzip, then you should see the folder appear here. Yeah, so it's MLDA cats and dogs. And as you can see, it's separated into cats and dogs folder. And each folder contains the images for cats and dogs. Yeah. So next thing to do is because, okay, let's go back to our pipeline. So second thing to do is to select and train the model. Yeah. So to train the model, firstly, we have to separate the data into the training and test data. So for me, I did a split of 90% test, 90% train, sorry, and 10% test. But of course, you can do it however you like. Yeah, so just press this to train, to sort of separate the data into train data and test data. Okay, so as you can see here, it's a size of 132. There's two labels, and the labels are cats and dogs, respectively, which is correct. Okay, now coming to the building of the model. So we are just using the image classifier model from Tensorflow Lite model maker, which is just the standard, sort of the gold standard model. But we are just using the basic one today. So model equals to image classifier dot create. We create a model with our train data because we want to train our model using our training data set. So just press play and train our model. So from the output, we can kind of see the architecture of the model, which is just a very simple architecture. And it shouldn't take too much time for it to be trained. Okay, nice. It's done already. So there's just 5 epochs. Okay, so next thing to do is to evaluate our model and see how it performs. So this is very simple. TensorFlow Lite has given us the evaluate function as well. So just press play and we can see the loss and the accuracy of our model on the test data set. And very nice. So our accuracy is actually 100% for the test data set. So this means that, yeah, our TensorFlow Lite model is good. TensorFlow model is good to go. And the next thing to do is to actually export it to TensorFlow Lite format, because if you want to deploy it to our mobile devices, it has to be a TF Lite format. Yep, so very simple as well, model.export. And this. Okay, hopefully it doesn't take too long as well. Just a second. Okay, so it's done. So it should appear, yeah, right here, model.tflight. Okay, so just to have a little bit of a bonus content. So the next cell we can see actually TF Lite actually supports a lot of industry gold standard models such as the efficient NetLite model, MoNet V2, ResNet, etc. So of course we are just using the standard one, but then we can definitely play around with different models, play around with different parameter configuration and things like that. Yep. So to view the results, let's just see, visualize how it performs. So this is just to see the results and see how well it classifies some test images. So let's just run this cell. Yep. So for our test data set, as we can see, the model is 100%. So cat, dog, 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 cat, dog, cats, dogs, dogs. Yeah, 100%. Cool. Okay, so right now, everything seems good to go. Let us just first download our model.tf Lite and get ready to deploy it to our mobile devices. Yep. Okay, so moving on, let's do Android first. So hopefully you guys have Android Studio downloaded as well as a physical Android device. So to download the Android example, just run this command git clone this in your terminal. Okay, so maybe I can just demonstrate real quick. So okay, so maybe just cd to the directory that you want. For me, maybe like desktop or something. Then just copy and paste the command and just press enter. Okay, yeah, because I have already downloaded it. So yeah, it says that it already exists. Yeah, but for you guys, it should be fine. Okay, so after downloading the example project, just open your Android Studio over here and just go into the example project that you just cloned. Yeah, so it's actually very, very simple. So for you guys, it probably has like a flower model.tf Lite or something because that was the model, that was the sort of that was that project that was being used. But for us, of course, we train our own model. So to sort of use our own model, what we have to do is just go to downloads or wherever you download the model. And yeah, just replace it, just replace the flower model.tf Lite with your own model. And yeah, and for me, I already done that. And okay, so next, and that's pretty much done already. So I will just demonstrate on my phone real quick. Just press play. And yeah, my phone is actually here, so you guys can hopefully see my screen. Yeah, hopefully you can see my screen. So this, yep. And as I go to the docs, this is an image of a dog, and you can see that the dog's percentage is pretty high, around the high 70s to 80s. And when I go to a cat, yeah, it changes to a cat. Yep, so that's the basic idea. So now hopefully that works for you guys. Yeah, maybe I'll just chill for about 5 minutes. So in case anybody has any problems. Okay, then I'll just answer some questions now in the chat. Okay, If I use iPhone, can Android Studio be used? Android Studio is to build Android apps. So if you use an iPhone, just wait for later because I'll be going through the iPhone example as well. Okay, so if there's nothing, then I'll just move on to the iOS example. Okay, so for the iOS example, it's also very similar. We just git clone this example. And yep, let me just do it with you guys. Terminal, then just go to the directory that you want, then just git clone this. Yep. Okay, so for this actually, let me just for this example, we have to cd to a new path. So let me just cd to that page first. Yeah. Okay, so firstly, we have to cd to Lite, cd to Lite. Then next we have to cd to examples. It's quite nested actually. Sorry. Give me 1 second, let me just do it out real quick. Okay, actually you don't have to cd, you can just like manually open. So these are examples folder. Just go to Lite, then examples, then image classification, then iOS. So you just open this folder in Xcode. Yep. So let me just go through again. So for examples, in examples, we go Lite, examples, image classification, then open this folder iOS, which is the iOS code. Okay, let me just open it up also in Xcode. Yeah, so just press image classification and open it Xcode. Okay, so for Xcode is also really, really simple. So in the model folder, by default, it has the model net something, something, something like TF Lite. So instead of that, we just pull in our own model, which I called dog and cat.tflight. And you just have to find all the usages of the classic model and change it to our own model. So maybe find the workspace. In this file, which is model data.handler, it has this num function, which specifies the model information. So it originally for you guys, it should be like model bnet dot something something. Just change it to your model. For me, it will be a .cat extension tflat. And one more thing before I forget, which is for labels, you also have to change the label to your own label. For us, of course, it's dog and cat as well. And if all goes well, just press play and everything should work fine as well. Yep, so of course, this is my phone. And as I point to the cat, you can see that the cat rating is pretty high. It's accurately identifies it as a cat. And if I go to the dog, yep, it's pretty accurate as well. So yeah, that's pretty much it. Yeah. And I'll just stay back for a while to answer any questions if there's any, hopefully.
Ray, you might want to show them how to get the data set manually. I mean, the TF.
Sorry.
I want to show
Okay.
I want to show them how to get the GitHub repo manually. Because some of them might not have Git installed, and
Oh,
they
right.
cannot run Git from the command line.
Okay. So for the if you guys don't have Git installed, so actually let me show you guys how to manually download the Git GitHub repo. One second. Yeah. So let me see. Yeah. So just click onto this. Then if you guys don't have Git installed in your command line, just press code and just download zip. It should work the same as well. Yeah. But if you guys have Git installed in your command line, then just yeah, just git clone this website, this link. But if you don't have, just press code and download it. That works as well. Yeah, hopefully that works for you guys. All right. So for Xcode, unfortunately, it's for Mac OS only. So if you have Windows, you are unable to use Xcode. And if you use Windows Com and Apple iPhone, then unfortunately, I think you can't really develop any apps. But but if you use Windows Com, you can download Android Studio and run the emulator. Yeah, but you won't be able to play around with the physical phone. Yeah. So how do I run it on Android Studio? Okay, so basically, let me just go through Android Studio again. So after you have cloned the repo already, then just open the folder in the Android Studio. Then for that we have a ML folder, and but it has a default TF Lite model. So just replace that model with your own model, and everything should work fine. Yeah. For iOS, it also works similarly, except for iOS, it's a bit more troublesome where you have to manually change the labels as well.
Ray, there's a lot of people who seem to be having problems with unzipping the file in the notebook.
Okay, sure. Then I'll go through it again, I guess. Okay, one second. Okay, so let me just restart this collab notebook. Okay, so at first, of course, we do not have anything. Just for unzipping, firstly, we will be in the table of contents, but we need to click the sort of the last button, which is house, and just pretend I do not have this. Okay, so let's pretend I do not have this zip folder first. Let me just delete the quick, and then we just delete this folder as well. Okay. Yeah, so first thing to do first is to drag and drop your cats and dogs zip folder into files and wait for it to load. Might take some time. Okay, so after it's uploaded finish onto the Google Colab, you have to be patient to wait for it to be uploaded finish first. Then you just run this code, this cell. So this is to unzip the folder, and I guess make sure that the name coincides with your actual one. So make sure it's mlda cats docs.zip. Then this zip file is of course also mlda cats docs.zip. So make sure that the name is the same. Yeah, and everything should work out. Yeah, for Android at least, if you replace the flower.tflight with your own custom-made tflight model, then the labels should change accordingly for Android. Yeah. Okay, so for Android Studio, it might take some time to sort of load the entire code if it's the first time running. So you gotta make sure that the compilation is finished before like the green button will show. So just wait for a while first before the compilation is done. Okay, so for the fake label 0 and fake label 1, etc. So okay, so for Android Studio, there's this small little problem. So because the original model file is called flower model.tf, right? So it's being used in a lot of places. So let me just search real quick, flower model. Yeah, flower model, blah blah blah. Yeah, so there's a lot of places that use this flower model thing. So after you replace it, you also have to replace all the flower models with your name in a sense. But for me, a little bit the quick fix is just to rename your custom model to be flower model.tf. Like, yeah, so everything will work out. But if you want to manually rename everything, that's also okay. But a quick way is just to rename your own model to be flower model.tf. Like. Okay, so to rerun, can we export the results after running our TFLite model to a spreadsheet? Okay, so for this question, actually, it's not really directly related to the TFLite for mobile devices. It's just a simple TensorFlow question. So with that, it's actually over here with view results where we can sort of you can sort of add some extra code to really label your results and the accuracy, and probably export it into a CSV file or something like that. So that is not exactly related to the mobile device. Okay, so for the TF Lite file, I'm assuming you're talking about the cats and dogs TF Lite model. So we have this collab notebook. Firstly, we got some data. We built our own model, custom model, and tested it out for the accuracy and stuff like that. And this step is the most important, which is we exported the model to a TF-Lite format. So on your left, it should show model.tf-Lite, and you just press these three dots over here and press download. Yeah, so that is where you get your TF-Lite file, because it's your own custom-made TF-Lite file. just download it anywhere because after you download the TF Lite file, you just have to make sure that you sort of pop it over to your Android Studio or Xcode project file. Yeah, sorry, I use a Mac, so not really sure if Windows face any general problems.
Ray, maybe you can let me share my screen and I can show how it can run on Windows.
Yeah, appreciate it.
Yeah.
Yeah, can you share screen? All right.
Okay. So generally speaking, after you go to the Android part, and then if you're using Windows, you'll be on this screen. So first, you need to check that your device, after you connect to the computer, is recognized by Android Studios. To do this, you have to enable debugging mode. And for most phones, it's disabled by default, and you have to turn on the developer options in order to enable this debugging mode. How you can turn on the developer options, you have to Google it, because for each phone or each version of Android, they have different ways to do it. So after you enable your developer options, you turn on debugging mode. When you connect your phone through the USB to your computer or your laptop, then you should be able to detect it over here. So over here, my phone is a OnePlus, and you can see it's running over here. And if you have compiled all your libraries and files properly, you let it run at the start. All you have to do is just press Run App over here. When you do, you just wait for a while, and it will turn up on your phone. And hang on, I need to disconnect my mouse in order to show you guys.
Yeah, you need to plug in your phone to the computer for it
Yeah.
to deploy the app to your phone.
Yeah. So Ray, maybe you can show them again how it looks like when the app is deployed successfully on your phone. Like this, how the screen on your phone should look like.
Oh yeah.
Yeah,
Sure.
I will stop sharing. Hang on.
Okay. Okay, hope you guys can see my screen. Yeah, so let me just go back to Android Studio. So my phone is a Google Pixel 3 XL, so it's detected. Then you just press play. Then on my phone, yeah, you will look like this. Very simple interface. Then if you sort of put any picture in front that is a cat or a dog, then you should be able to classify them. Yeah, so it's a cat. And this is a dog. Yep. Okay, Jenny, you want to share your screen again for the Windows users? Yeah, I'm a code. Yeah.
I cannot show them how it looks like on my phone.
Oh, cause you didn't sort of enable the screen sharing for your phone, is it?
Yeah.
As in show them how to run it like in Windows. But I think a lot of people use Windows probably.
Okay.
Or is anybody facing any issues and happen to be using a Windows computer? If no, then I guess it should be fine.
Yeah, for that you have to, like I said, you have to enable debugging mode. But before that, you need to turn on developer options.
Yeah, so every phone is different for turning on developer options since it's like, for example, Samsung phones, Android, Google phones, they're all different in turning on developer options. So you have to just search it up on your own. Okay, so just some extra tidbits. So for this TF Lites format, you can deploy it to devices other than mobile devices as well. So like I mentioned, mobile devices and IoT devices, so your Arduinos and your other hardware stuff, it works as well. Yeah. But today, of course, I'm just demoing Android and iOS because I do not have like the other hardware devices with me. Yeah, so actually these two things are my phone. I'm just mirroring the screen. So if you want to see what's going on, let me just, yeah, it's supposed to look like this, the interface. So just a very simple TensorFlow Lite and yeah, the image tables below here. Okay, I guess if no other questions, then I will end the workshop over here. So hopefully everybody learned something about deploying TensorFlow models to mobile phones. But I'll just stay back for about 5 more minutes in case anybody has any last minute questions. Yeah. Uh, okay, for the recording, I think it'll be uploaded somewhere, but not really sure where it will be uploaded. Jun, do you know where it's uploaded?
Yes, it'll be uploaded on YouTube after we process it.
All right, cool.
Wenzhen, you have to enable debugging mode. So again, to enable debugging mode, you need to enable developer options first. And to do that, you have to Google how to do that for your phone.
Yeah. Yeah, if anybody has any last minute questions, just feel free. May I know how production of ML app will, what is under FPS? Oh, may I know how production of ML app will develop? Uh, Not really sure what do you mean. Maybe just you can just turn on your mic and just verbalize your question, I guess.
Oh, hi. So my question is, how will the production app will be developed? So it's like, because now what we do is really like a development testing, right? So we actually unsure of how, the accuracy of this. And I saw there's the demo that you're presenting, right, is also just checking for dog and cat, right? So what if you present you're trying to capture the other things? So the confusion metrics, the result will not be very effective, right? So I'm just curious, right? So how the production app, like what they undergoing the testing will be, like what they do to ensure the end result is promising. Like Google every time you release a more ML functions or ML app on their Google Cloud product, right? So it's always sounds promising. So I just wonder what is the process or what they has done to achieve this. Yeah, thank you.
I'm not sure if this answers your question, but typically what we do is we just base our results on the testing set. So what you'll have is a train and test set, right? And if your training set is representative of the test set, which is also representative of the real world application that you want to use it on, then if your model performs well on a test set, it will perform well in the real world as well. However, if the real world application is very different from your test set and your training set, then it's going to be very difficult to judge the performance of the model. I'm not sure if that's what you're trying to ask, but
Right. Yeah, thank you for answering. So, because this will make assumption that you have a very large data set, right?
Yes, that's right.
So if I don't have a large data set and then I want to deliver a promising result, could it be possible? Yeah.
Yes, so that's where we use transfer learning. Like previously in a workshop, how this works is that the model itself is really trained on a very large data set, millions and millions of images. And all you have to do is to train it again, like we showed. Actually, the cats and dogs one, we only train it on like 132 images, and it could perform very well after that. So if you do not have a large data set, it shouldn't be much of an issue with transfer learning. You should be able to get pretty promising results.
I see. Thank you very much.
Yeah, no problem.
They are accidentally disconnected. Yeah.
Okay, all right, everyone. I believe that's it for everyone. And if you have no further questions, we will end this workshop very soon. So if you have any last minute questions, please go ahead and ask them. If not, I will close this workshop. Thank you all for coming.
Thank you.
Have you enabled debugging mode? Just developer mode is not enough. You need the debugging mode as well. Transfer learning is where you use a model that's trained on a very large data set, and you train it again on a smaller data set catered towards your needs, and you'll be able to use the features that you learned from the large data set and apply it to your smaller data set. So that's typically how transfer learning goes. Yes, the video will be recorded on and uploaded on YouTube, but you have to wait for some time. No, a pre-trained model is where the pre-trained model is what you use for transfer learning. So they are very closely related, but they're not the same.
Okay, so for what should you do after enabling USB debugging? After you enable USB debugging and you have enabled the developer mode, after you then you can plug in your Android device to your computer. And after you open Android Studio, it should detect that your device is connected. Then you can just simply run the app and it should work.